This video is for Pre-Algebra Chapter 1, Lessons 7 and 8. This has to do with patterns and inductive reasoning. Inductive reasoning is making conclusions based on patterns you observe. And then the conclusion you reach because you observed those patterns is called a conjecture. So if I notice some patterns and then I say, okay, well then because I've seen these patterns and because of that I think I know what's going to happen next, that's the conjecture. So thinking what you thinking what you know is going to happen next is your conjecture. How you got to that conjecture is through inductive reasoning. Okay, so my example is because of inductive reasoning, I made a conjecture. All right, so here we have a pattern, and I'm going to look at the teal boxes with the red diamonds in the middle. And as you can tell, there's little triangles, or close to triangles, shaded in with green. So based on the first, second, and third triangle, what is the fourth triangle going to look like? Well, based on inductive reasoning, since the first one started here, and then the second one went there, and the third one went there, I can probably imagine that it's going clockwise, so the next one should be in the next empty triangle clockwise. So that's what the next one in the pattern is going to be. Alright, so for the next pattern we have three circles with polygons in them. The first one has a triangle, which is a three-sided figure. The second one has a square, which is a four-sided figure. The third one has a pentagon, which is a five-sided figure, and so the next one should have a six-sided figure, which is what we call a hexagon. I had to look that up real quick because I couldn't remember, but a hexagon has 6 sides. So I'm going to try and draw one for you right there. There we go. There's a kind of shaky six-sided figure, but it's got 6 sides. And again, this is my conjecture based on my inductive reasoning. Alrighty, so there we go. Alright, next slide. Next we're going to talk about patterns and writing rules for patterns. And when you write a rule for a pattern, you always have to say the number you start with. Because if you tell somebody a pattern and you don't tell them where to start, they're going to get off because they might not start in the same place that they are supposed to start at, because if you apply one pattern to a different number, you're going to get a different result in the end. And so I'll give you an example of that once we go ahead and do the examples below. And then the second thing you do after you give the starting number is describe the pattern with the numbers and the operations or words. So for this pattern right here, the first one, it starts with 4, right? And then it goes to 9, 14, and 19. So what's actually happening here? Well, how do I get from 4 to 9? And it should be relatively or close to the same reason of how I get from 9 to 14. Well, most people know that 5 plus 4 is 9. Well, if I add 5 to 9, I'm going to get 14, and 14 plus 5 is 19. So that's pretty much my pattern. I'm going to start with 4, or start at 4, and then I'm going to add 5 each time. So here's going to be my example of starting at the wrong number. Well, if I start at 3 and add 5 each time, it's going to be 3, 8, 13, 18. Is this the same pattern as that? No, and that's because I started in a different place. So even though I'm using the same pattern, starting in a different place is definitely going to give me a different answer. So you have to make sure you give the starting point. Because if you don't tell somebody where to start, the directions are useless. And you'll notice that if you're doing the same thing with like driving directions. If I tell you how to get to my apartment from Carl's Jr., if you start at McDonald's, you're probably not going to make it to my house. And even if you did, you didn't follow the directions I gave you exactly because you started in the wrong spot. It's the same thing with these patterns. You have to start in the right spot. Okay, next up, the next pattern right there. This one's a little tricky because the pattern is actually not consistent, or at least it's not consistent every single time you use it. Something might be different. So how did I get from 1 to 3? Well, I can add 2, or I can multiply by 3. But what's the next thing that happens? Well, the next thing that happens is 3 to 4. Well, the only way to get from 3 to 4 is to add 1. But then, how do I get from 4 to 12? Well, 4 to 12, I can either add what? I can either add 8 or I can multiply by 3. Oh, but that multiply 3 was a possibility from the 1 to 3. So maybe that's what's going on. And then if I'm going from 12 to 13, that's an increase of 1. Well, that was the same increase of 1 that I went from 3 to 4. So this pattern is actually a little crazy, and I wanted to show this example to you guys because it can happen in the assignment you're going to have to do on Monday, because I'm recording this on a Friday, by the way. So there we go. So you're going to start at 1, and then you're going to multiply by 3, and then add 1 alternating, because the first time you multiply by 3, the second time you add 1, so that's a multiply by 3. The second time you're going to add 1, the second time you're going to multiply by 3, and the next time you're going to add 1. So basically it's an alternating pattern. You do this and then do that, and then you go back to the thing you did before. So that's how you would write the rule for that one. All right, next up we are starting with 640, and then we go down to 320, 160, 80. Well, I can either subtract 320 and then subtract 160 and then subtract 80, but that pattern's not very consistent. You're not going to help anybody out because it's a lot of directions. But there is something else that's going on here. If you notice, 320 is half of 640, and 160 is half of 320, and 80 is half of 360. Well, how do you represent a half? Well, guess what? You can divide by 2. So we're going to be starting at 640, and we're going to divide by 2 each time, and that's going to get our answer. So the next one after this would be 40, because 80 divided by 2 is 40. 40 divided by 2 is 20, 10, 5, and then you're going to start getting into decimals. You don't need to do that. Though, in some of the questions, they may ask you to find the next few numbers in the pattern. Just make sure you can apply the pattern to the last number they give you. Okay? Alrighty. Next slide. All right. Oops. Let's not give you the answer just yet. Okay, so you are going to, for one of your lessons, have to look at a statement and figure out if it's true or false. Is the statement true? Does it, every time you do this statement, do you always get the right answer based on what the statement says? If not, if there's something that disproves the statement, that's called a counterexample, something that proves it false. And usually a definition of a term is going to help you prove something false. So for number 1, it says all four-sided figures are rectangles. Well, if I build a four-sided figure right here in red, is that a rectangle? No, that does not look like a rectangle. That's actually what we call a trapezoid. And trapezoids are not rectangles. So the statement, all four-sided figures are rectangles, is a false statement, and the counterexample would be a trapezoid. So false, counterexample, trapezoid. Next statement, the absolute value of any integer is positive. Well, if I have the absolute value of -2, the absolute value of -2 is 2, so that's true. And if I have the absolute value of 3, it is 3. So the absolute value of any integer is positive. So this is a true statement. So the next statement we have is a number and its absolute value are always positive. Well, here we have a statement of the absolute value of -2 is 2. Well, that's true because the opposite of -2 is 2. So that makes the statement true. But what about this example? The absolute value of 3 is 3. 3 and 3 are not opposites because they're both on the same side of the equals of the 0. So this is false. So this example right here is actually the counterexample to make a number and its absolute value are always opposite a false statement. So that's false. There we go. And the counterexample is the absolute value of 3 equals 3. All right, we're on to the last slide. All right. The last slide is about word problems. So you will have some word problems on Monday. Hopefully not too many. I think you only have like 2 or 3. But no promises because it's Friday and I might change my mind by Monday. Okay, so we're going to go ahead and look for patterns and make a chart. So here's the word problem. News spreads quickly at Riverdale High. Each student who hears a story repeats it 15 minutes later to 2 students who have not yet heard it and then tells no one else. So suppose one student hears news at 8 a.m. How many students will know the news by 9 a.m.? So let's go ahead and start with the first student. This is 8 o'clock. Where's my 0? There we go. And by 8:15, they've told 2 other people. So by 8:15, 3 people know. The first person who knew it and the 2 people they told. So we're up to 3 people who know by 8:15. By 8:30, each person who just found out at 8:15 now tells 2 other people. So person 2 tells person 4 and 5, and person 3 tells person 6 and 7. So by 8:30, we've got 7 people who know. By 8:45, we now have 15 people who know, because person 4 told person 8 and 9, person 5 told 10 and 11, 6 told 12 and 13, 7 told 14 and 15. So 15 minutes later, 8, 9, 10, 11, 12, person 8, 9, 10, 11, 12, 13, 14, 15 now tells 2 more people, which is a lot of people. You get up to 31 people by 9 o'clock. So here's your chart. Use it. Make sure you can apply it to other problems. Sorry the video was a little late. It's a Friday, so I'm wishing you a happy weekend. If you're not watching this on Friday, I hope you had a good weekend anyway. All right, guys, bye.